Hey, it's Dr. J. We're going to finish chapter 4 today. Finally, it seems like the chapter that will never end, right? So we're going to end off with, where I basically ended every chapter with equations. Today's equations are going to involve fractions, which is in the spirit of the chapter that we've been studying. So we already have a couple principles that I want to review. Some people call them properties, some people call them principles, other people call them laws or rules. I'm just going to go with what we've been calling them all semester, which is the division property. So if I had something like this, and again, I'm not going to label this as an example because I'm just going to kind of use this as the introduction. The division properties basically says that you can divide both sides by the same number. That number we call the coefficient. It's a word you should definitely get to know. It's a fancy way to say the number that is multiplied by the variable. And it's an invisible multiplication. We typically don't write 3 times x because it's a little bit redundant. We just write 3x. So the division property basically says you can divide both sides by the coefficient, and the equation remains true. Yeah, it's a true equation or a true statement. We also have the multiplication property. And the multiplication property basically says the same thing. It just is in reverse order. So if you have something like this, x over 5 equals 3. Again, now this is a little bit tricky. 5 is not technically called the coefficient. This actually means with division, so when you divide a variable by a constant such as 5, it actually means 1/5. Yeah. So, yeah, I know you don't see the 1/5, but there's an invisible 1 right here in front of the x. And so, although I rarely ever write this, I typically would just write x over 5. Occasionally I'll write 1/5 x just to emphasize that it means the same thing. It does not mean this, 1 over 5x. That's not true. So don't do that. All right, so the x either goes in the numerator or you can put the x off to the side. And it really doesn't matter that it's x. It's whatever the variable happens to be. And so what the multiplication property says, it basically says the same thing as the division property. But instead of dividing both sides by 5, you would be multiplying both sides by 5. And it really doesn't matter what side you multiply on. I just go wherever it fits. And then you can cancel the 5s. But remember what canceling actually means. Canceling actually means it becomes 1. So in math, we often say, oh, it canceled, right? But it's a loose word, right? In this particular example, canceling means it actually simplifies to become 1. Yeah. So you have 5 times 1/5. We normally notate it like this. We just cross off the 5s. But really what's happening is it's 5 divided by 5, which becomes 1. And then we typically don't write it. We don't write the 1. We just write x equals 15. Although, on a test, if you typed 1x equals 15, I would have to mark it right, because technically 1x is the same as just x. I haven't had anybody do that yet, but it's still out there if it happens. So what am I getting at here? So this is all a review of the previous sections that we talked about. Today we're going to do this with fractions. And we're going to combine these two properties together. And we got to give it a name, yeah? You could call it the division/multiplication property, or you could call it the combined division and multiplication property. But it turns out that when we combine these two properties, we just call it the multiplication property. It's as if they joined together, became one property, and then they took the name of this property. Yeah, they got married, so to speak. Okay, and they took the name of the multiplication property. And the reason why it takes the name of the multiplication property and not the division property is as we're moving forward in math, in this class and in your next algebra class, and ultimately through your college level mathematical life, you will hear professors, including myself, refer to this simply as the multiplication property. And so that is used when we have a combination of multiplication and division, also known as a rational number or a fraction. So something like this. All right? So if I have a equation involving fractions, we use the multiplication property, which is a combination of the division and the multiplication properties. And we multiply both sides. Multiply both sides. Make sure you do both sides by the reciprocal of the coefficient. That's what we refer to as the multiplication property with fractions. Reciprocal is a fancy way of saying flip it over. I've got to scoot that over. So this is called the reciprocal, also known as the flip, not called the opposite. It's a very common misnomer is to call it the opposite because it's upside down, and that kind of seems like an opposite, but it's not. It's a reciprocal. All right. And now what happens is we multiply the numerators. So 3 times 2 is 6. 2 times 3 is also 6, so that becomes 6 over 6. On the right-hand side, we multiply the numerators. 8 times 3 becomes 24, and 1 times 2 becomes 2, and then we simplify our answer. Again, this is 1x, but I'm not going to write the 1, and then 24 divided by 2 is 12. And that's so the solution is 12. Okay. So that's what we're doing today. We're going to use the multiplication property using fractions. I guess you could have called this example 1, but why don't we call this example 0? And I'll start my lesson officially now with example 1. So solve for x. It's the most common variable, although I might start changing it up a little bit today and use some different variables. So what if I had 4/5 x equals 12? Okay. So the reciprocal of 4/5 is 5/4. These guys are going to cancel out. Yeah, I'm not even going to show what it is, right? It's 20 divided by 20, which is, again, just 1. If you have a whole number or an integer, it's a denominator of 1. So you have 12 times 5 is 60. 1 times 4 is 4. And 60 divided by 4 is 15. All right. You can also do it this way. I'll call this the alternate method. The alternate method would be 4 goes into 12 3 times, and then 3 times 5 is 15. That still works. I recommend knowing both methods, because sometimes doing it this way is actually better. It actually causes less problems. It causes less mistakes. And in my world of view here, if something has less mistakes, then it's better. That's my definition of better. If it makes your life easier, if it's going to make you more successful, then that's what I want you to be able to do. The alternate method is good, yeah, but it's dangerous. People screw this one up all the time. They make some kind of small little error and they don't even realize they did it. So I'll do it both ways. Sometimes I'll do the danger method and other times I'll do the safe method. All right. Let's do some more. A lot of these today. Solve for the indicated variable. Or I could just say solve. Let me use a B instead of an A. So 7/9 B equals, what should it equal? About 6. 7/9 B equals 6. I did this to indicate the difference between a B and a 6. Now I write them very carefully. I've seen a lot of sloppy B's in my days where they sort of look like 6s. So this is a good exercise in preciseness, writing your letters and numbers precisely. All right, so the reciprocal is 9/7. 9/7. Cancel, 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 cancel. Again, that's 1. 1B. All right. No canceling. So we're going to go 6 times 9 is 54 over 7. And I want you to leave as an improper or a simplified fraction. Simplified is also called reduced fraction unless specified otherwise. I'll just say that now, and this is going to stand for the rest of the semester. Whenever we have a problem involving fractions and you get a final answer, I just want you to leave it either as an improper or simplify it as much as you possibly can. But we try not to do mixed numbers unless specified otherwise. So such as mixed. Occasionally I'll specify mixed numbers when I really want to use them. It's not very often. It's 1 out of every 40 problems or something. 1 out of every 20 maybe at the most. Okay. Example 3. You could have negative fractions. Let's change it up a little bit. Let's do y. Okay, now do not use the opposite. So a very common mistake, and I understand why it happens, because earlier in the semester when we were learning the basic integer equations, or whole number equations even, I would always say use the opposite value, all right? But that's not true when we're talking about coefficients, multiplication, division, fractions, things like that. We're not going to use the opposite. The reciprocal of negative 2/3 is negative 3/2. So you want to use the reciprocal, which is negative 3/2. I don't care where you put the negative, but I usually put it on top. And I like to use parentheses whenever I have fractions, especially when they are negative. You know why I use the parentheses? Because see what happens if you don't use the parentheses? What does that look like? It looks like minus. Yeah, it looks like subtraction. Okay. So the parentheses just ensure that my brain does what I intend it to do. Yeah, to multiply, because that's what I'm trying to do here. All right, the negative and the negative are going to cancel. Yeah, multiply two negatives, you get a positive. The 3's are going to cancel. Yeah, 3 divided by 3 is 1. The 2's are going to cancel. 2 divided by 2 is 1. Yeah. So we just say y. Yeah. And then over here, I need to be careful now. Okay, I've got 4 times negative 3. I like to associate the negative with the numerator. It just looks a lot nicer. So that's negative 12. And again, if you prefer, you can put the negative out in front. And then 9 times 2 is 18. And then you want to reduce this as possible. So 12 is 4 times 3. 18 is 6 times 3. And keep going if possible. 4 is 2 times 2. And 6 is 2 times 3. I had to take that one off in little bite-sized chunks. If you see it right away, I probably could have done it all at once. So my answer is negative 2/3. My solution. Now that I've finished the problem, I realize that I could have probably done it a little easier. Right here, I could have done, so we'll call this the alternative method. I could have done 2 times 6, and then 3 times 6, canceling the 6's, and my answer, my solution would have came out a lot faster. All right, but I'm not really in much of a hurry, right? I'd rather be right and spend 1 or 2 extra seconds than try to rush it and get it wrong. Yeah. But again, that's a personal choice for you. I really don't have to tell you what to solve for. I really can just say solve, right? There's an implied variable, and there'll only be one variable, so whatever the letter happens to be, that's the one that you're going to do. So probably moving forward, I'll just say solve. Yeah, but I'm just being very, very clear here. Solve for x. Okay, so this kind of goes back to the introduction of this section. If you see a denominator and you do not see a numerator, that means that there's an invisible 1. So this fraction really means negative 1/5. It's like there's an invisible 1 right there. And again, just to be safe, I like to put the negative in the numerator. Right. In fact, sometimes I'll even go like this, and I'll make my fraction bar much larger so that it clearly looks like the negative lives upstairs. I mentioned this before. It really doesn't matter where you put the negative. But if you consistently do it the same way, you're sort of building a system that's going to last probably for the rest of your college career. All right. However long that might be. It could be 2 more years, could be 10 more years. I don't know. But we want to start now. So again, don't use the opposite. What's the reciprocal? And again, I'm putting some parentheses here to be safe. The reciprocal of negative 1/5 is negative 5/1, which you could simply write as negative 5. These mean the same thing. And now cancel. Negative and a negative are going to cancel. 5 and 5 are going to cancel. And you don't really have to cancel ones, right? Ones are already 1. They don't need to be canceled. And then I've got negative 2 times negative 5, which is 10. Okay. So that's the multiplication principle as it relates to fractions. Or property. Principle, property, rule, law. It's all the same. I haven't really been checking my answers, but so before I move on, maybe I'll do a quick check for assurance. If you're getting it wrong and you're not sure why, or if it's a quiz and you just don't want to get it wrong and you want to make sure it's okay, take the original problem, just like it's originally written, and then plug in this value, which we call the candidate. Until it's been checked, it's a candidate. It's not a solution yet. And then simplify it. Don't try to solve it, though. I have seen students get the right answer. They go to check their answer. Then they try to solve their own answer. And then they just end up screwing it all up, right? And that, if you're one of those folks, I would rather have you not check. Or just leave it alone. My mother used to say, Leif, put it down before you break it. All right? And I'll tell you the same thing. Okay? If you're going to screw this up, then just don't mess with it. All right? Just solve it and walk away. Say, I'm done. Okay? Not my problem anymore. But for those of you that are paying attention to detail and want to do this correctly, I'll show you the right way. So this is negative 10 divided by 5. Again, I'm not solving this. I'm just evaluating it. Negative 10 divided by 5 is, in fact, negative 2. So it checks out. All right. I'm only going to do that once today, probably. It takes too much time to check every single answer. But it is a little bit of an insurance. Or you can call it assurance. Either way. Next, we return to the addition and subtraction principle, or property. I don't really have much to say about this property. I'm just going to do an example. I don't have a big backstory on this one. This property, once you learn it in chapter 1 or chapter 2, whenever we originally learned it, that's it. This property never changes. And even when you get into really, really advanced mathematics, you could be in 3rd semester calculus, and this property is still exactly the same property as it was, 10,000 years ago when your ancestors first discovered this property. I'm saying solve for x again. So we've got x plus 7/2 equals 1/2. The only difference in this chapter is all of the problems will have at least one fraction. All right, at least one fraction. This one has 2 fractions. It's the same property. You look for the addition or subtraction term. We call that an addend, a fancy way of saying the thing that is being added or subtracted. Turns out that subtraction, if you remember, is the same as addition. It's the same property. And we add the opposite, not the reciprocal, with this property. So the addition and subtraction property says add or subtract the opposite. In this case, I'm adding negative 7/2, which is also called subtracting. So one person might say subtract, another person says add the opposite. Means the same thing. Tomato, tomato. So when you add the opposite, it liberates the variable. So now the variable is an isolated term. It's all by itself. And you have negative 7/2 plus 1/2. Or if you prefer, 1/2 minus 7/2. Again, tomato, tomato. Those mean the same thing. These will both give you the same result. Fortunately for us, this already has a common denominator. Yeah, that's nice. That's what I call the honeymoon. Yeah, it's not going to last long. So you got -7/2, +1/2. That's going to be -6/2, which reduces to -3. Notice if you do it this way, you still get -6/2, which is still -3. So it really doesn't matter, tomato, tomato. Let's call the whole thing off. From now on, I'm just going to say solve. All right, x plus 4/5 equals -2/3. All right, so we're going to add the opposite to both sides. Okay, now I want to point something out here. You are adding two negative numbers. All right, you can write it like this. Even if you write it without a plus sign, it still means plus. Yeah. I think I made a really big deal about this a couple chapters ago, right? Everything is adding, right? Even when you think you're subtracting, you're adding. Remember, multiplying is really adding. Everything is adding. It turns out there's only one thing in the world. That's adding, at least mathematically. All right, now the bummer is we don't have an LCD here, so we're going to need an LCD. Now these are prime numbers, 3 and 5. So remember what I said about prime numbers. The LCD is just going to be the product of those prime numbers. So you're just going to multiply 3 times 5. Make sure you do the top and the bottom. And then 5 times 3, make sure you do the top and the bottom, numerator and denominator. So you got -10/15 plus -12/15, and that's going to be -22/15. I would normally try to simplify this, but 22 is 2 times 11, and 15 is 5 times 3, and they don't have anything in common, so I'm not going to waste a bunch of time trying to make something simple if it cannot be made simple. All right? It is what it is. It's already simple. It's as simple as it gets. Or it's as good as it gets. It doesn't get any better than that. How about one more of these? X minus 1/2 equals -2/3. So we are going to add the opposite of -1/2, which is +1/2. Sometimes we refer to this as moving the term to the other side. It's a little loose way of saying it's just kind of jumped over the equal sign onto the other side. Whoa, and look what I just did to my camera. There we go, we're back. So I've got -2/3 plus +1/2, like that. Again, the denominators are prime numbers again, and they're not the same prime numbers, so I need to multiply them by each other. So this one I'm going to times it by 2, top and bottom. And this one I'm going to multiply by 3, numerator and denominator. If you stick around long enough, you'll get so good at this. As soon as you see the numbers, you'll just instantly multiply them by the right number, and you can skip to this step very quickly. If we ever go back to school or in the classroom and you're taking notes in the classroom, that's a good way to keep up with the board work by kind of anticipating the step. You already know it. You're already writing it down before the professor even writes it. Negative 4/6 and positive 3/6. Remember, you subtract, so that's 1/6, and then give it the sign of whichever numerator is larger. And again, I'm using the word larger very loosely. I mean farther away from 0. That's the loose way to say larger. So negative 4 is technically, well, it's not technically, it's loosely larger. Technically, negative 4 is actually smaller, and that's why I have to be really careful with the way you say it. Okay, so that is the addition and subtraction property. And now you probably already know what's going to happen. We're going to combine the two properties together. We're kind of just walking in our footsteps of the previous chapters. It really is the same basic concept. It's just going to be harder because everybody loves fractions, right? Or it's going to be more fun because everybody loves fractions. Okay, so we are going to combine this all together. Now there are two different techniques. Okay, I'm going to show you both of them. Number one is called deal with it. And that's a slang term for dealing with the fractions. And when I say deal, I'm trying to say everything that we've ever learned about fractions. Least common denominators, reciprocals, negatives. Just deal with it. It's going to be messy, but you're just going to have to deal with it. The second method is called get rid of it. Annihilate it, kill it, destroy it, get it out of your life completely, right? And those are really your only two options. Yeah, the problems are going to keep coming, right? You're going to have problems. You either have to deal with the problems or you have to get rid of the problems, one or the other. Now, some people philosophically will say, well, when you get rid of a problem, aren't you actually dealing with it in some way? Well, yeah. Let's go through one of these at a time. Ultimately, when you get really good at math, you'll realize that these two methods are essentially the same method. It's the same coin, right? One of them's heads and one of them's tails of the same coin. I like to show you the deal with it method first because that's the more complicated method, and it's what I've been talking about for the last 33 minutes or so. And so it kind of goes right in the theme of this lesson, right? But then I'll talk about the get rid of it method in a little bit. All right, deal with it. So method number one, deal with it. So I'm literally just going to go through all of the steps, and it's not going to be fun. Well, it might be fun. I shouldn't be putting words in your mouth. You might actually enjoy this. All right, so again, I'm just copying it down one more time. I'm going to go through all the steps. You always want to use the addition and the subtraction principles first. So you want to get rid of any of the addends. Terms, things that are being plus or minus in the equation. Addition and subtraction. You always want to use the multiplication principle last. So this 1/5 is going to be the last thing that I deal with. So now I've got negative 3/8 and negative 1/4. This time they're not prime, right? They're not prime numbers. So I don't want to just multiply them by each other. That would give me 32, which is way too big. Yeah. We want to use the least common denominator. So the LCD is going to be 4. Goes into 8 2 times, so the LCD will be 8. I almost said the LCD was 4, but I caught myself. The LCD is 4 times 2, which is 8. Okay? So I'm going to multiply this by 2 in order to make the LCD equal to 8. Again, that's the mental math way of doing the LCD, which I'm going to start leaning more on the mental math and less on the mechanical step-by-step procedure, because you don't want to have to take out scratch paper and work out this whole system before you can even go to the next step. You're never going to make it through if you have to do that every single time. So once in a while, step it up a little bit and take a jump, take a leap. So you got negative 3/8 minus 2/8. That's negative 5/8. I am running out of room, so I'm just going to bring it up here. So I've got 1/5 x equals negative 5/8. Remember how I like to put the negative in the numerator? And then now I'm going to multiply both sides by the reciprocal of 1/5, which is 5 over 1. Or if you prefer, you can just write 5. There is a danger to just writing 5. Yeah. It's just called sloppy writing. That's what's dangerous about just writing 5. And if you go 5 times 5 and make it 25, it's going to be wrong every time. And if you go 5 cancels 5, it's going to be wrong again every time. So even though I say you can, I don't mean you should. I mean, you can, but you should write 5 over 1. It's the safer way to do it. Cancel the 5s. You don't really need to cancel the 1s. Right? 1s are already 1. They don't need to be canceled. And then I got negative times a positive, so that's negative 25. 8 times 1 is 8. And that is irreducible, negative 25 over 8. Okay, so that's the deal with it method. By the way, I made up the phrase deal with it. The official method is the least common denominator method. You know, that just doesn't sound as catchy as deal with it. All right. Now let's do the other method. And then from here on out, for the rest of the lesson, I will just choose one of the two methods depending on the problem. Sometimes I'll deal with it. Sometimes I'll get rid of it. So method number 2. Get rid of it. And when I say get rid of it, what I really mean is get rid of the fractions. Because that's really what people fear the most, right? If I were to do a survey, I forgot the problem. What was it? 1/5 x plus 1/4 equals negative 3/8. That's it, right? Good. If I were to give a survey to my students, which I often do, I haven't done it with you guys yet. Maybe I should put an online survey, maybe ask, but I already know what's going to happen. 90% of my students will tell me they don't like word problems and they don't like fractions. Those are the two things that most people fear the most. I'll get to the word problems later. First, we're going to resolve the fractions. So when I say get rid of it, what I really mean is get rid of the fractions. How do we get rid of the fractions? And the way we do it is we multiply all the numerators, and that's an important distinction, not like in the deal with it method. The deal with it method, you're multiplying the numerator and the denominator. This is a slightly different method. You're only going to multiply the numerators by the LCD of all the denominators. So you're going to look at all of the denominators and multiply by the LCD. This time the LCD is much bigger because it's the LCD of 5, 4, and 8. That is 40. Yeah, 40 is the smallest number that is divisible by 5, it's divisible by 4, and it's also divisible by 8. You certainly don't want to multiply all of these numbers together. You'll get like 160 or something. It's much, much too big. Yeah, so you want to be minimal, least, but it has to be common as well. All right, so it's like you're finding the cheapest way to solve the problem. And you want to multiply all the numerators by the LCD. I don't really care where you do the multiplication. You can do it on the left. You can do it on the right. You can do some of them on the right. You could do some of them on the left. It doesn't really matter. It does matter that you do it in the numerator, though. That's the most important thing. And the wonderful part about this method, in fact, I'm already kind of condoning this method over the other method, is immediately your problem gets better. You see how nice that is? Look at that. In one pass, 40, 40, 40, I just multiplied all of the numerators by 40. And then the denominators just disappeared. Look, 5 went into 40 8 times. 4 goes into 40 10 times, and then I multiplied 10 times 1 and got 10. 8 goes into 40 5 times, and then I multiply 5 times -3, and I got -15. And the nice thing about this is now all the denominators are gone, and that's why I call it the get rid of it method. Yeah? All the fractions are gone. You essentially have an integer equation where everybody is an integer. Now you can just solve it the same way you would in a previous chapter. Everything new, everything old is new again, right? Remember, you were adding these negative numbers, so that's -15 and -10. Even if I don't put a plus sign, that automatically means addition. Yeah? You're just adding negatives, which is kind of like subtracting. Yeah? And remember, we should get the same result. We're going to divide both sides by 8, and we get the same result. Tomato, tomato. Okay, so there you go. That was the big, long, drawn-out explanation of the two different methods to solve an equation. If you don't like two methods, you just want to have one way to do every problem, then pick. I'm giving you a choice. If you don't want a choice, you want me to pick for you, I would pick this one. I would pick the get rid of it method. That's my doctor's recommendation. I kind of lost count. I think that was example 6 and 7 because I kind of did it twice, but I don't know. It doesn't really matter. I don't even have to number them if I don't want. It's mainly so that when you're taking notes, you can keep track of where I'm at. Okay, let's try another one. 1/5. No, we already did 1/5. We already did that one. 3/4 y plus 5 is equal to 1/3 y. Uh-oh. Got blurry on me. Come back to me. Come on. Don't make me quit now. You know, sometimes technology is more trouble than it's worth. I'd rather have a camera that just didn't focus. Come on, just stop trying to autofocus on me. I think I already mentioned I turned off the autofocus, but that thing has a mind of its own. There it goes. Okay. So again, choose your method. I'm going to go with the get rid of it method this time. Yeah. If you want to know my philosophy, if there's more than one fraction, I like to do the get rid of it method. If there's only one fraction in the whole problem, I just do the deal with it method. Because, I mean, one fraction, I can deal with it. If there's more than one, then I want to get rid of it. So the LCD is 12. Yeah, 4 and 3, 12. So we're going to multiply all of our numerators by 12. 12, 12, 12. Make sure you do all of them. Numerators only. So don't hit the bottom with the 12. So this is going to be 4 goes into 12 3 times. 3 times 3 is 9. And don't forget it's a variable y there. 5 times 12 is just 60. A lot of people forget to do the whole numbers because their brain goes, well, it's not a fraction. It doesn't need an LCD, right? So it's sort of like justifying why you don't have to do that, but you do. All right. The key word there is all. Everybody gets one. And there's no canceling on that. It's just 5 times 12. And then on this one, it's 3 goes into 12 4 times. 4 times 1 is 4y. Now, I have variables on both sides of the equation, and they must be together, combined on the same side. 90% of the time you've seen me solve these equations, I'm always pushing my variables over to the left. But this is the exception. Because I have a constant and a variable on the left, I'm actually going to go the other way. I'm going to be left-handed for this one problem. So 9 minus 9, those are gone. That's another type of canceling, by the way. I try not to call that canceling. That's called adding to 0. Or adding the opposite. Some people refer to that as canceling. It is. It's fine. It's just a different type of canceling. Yeah. And then over here, you're going to have negative 5y. Make sure you remember the rules of negative numbers. 4y, negative 9y, you're adding those together. Or if you prefer to call it subtracting them, you get negative 5y. Finally, I want to get my y isolated, so I'm going to divide both sides by negative 5. 60 divided by negative 5 is negative 12. Typically, you rewrite your answer this way. Yeah. Y equals negative 12. That's the traditional, we call that the right-handed presentation or solution or whatever you want to call it. It's okay to be backwards, but as long as you understand that these mean the same thing. Okay, this one only has one fraction. One fraction, 2/3. So I'm going with the deal with it method. The deal with it method. I'm only going to have to deal with it one time. So let's just go for it. I don't have to multiply by the LCD. It's not necessary, because there's only one fraction. So I'm going to subtract 8 from both sides. 4 minus 8 is negative 4. And now I'm going to multiply by the reciprocal. Remember, top and bottom, though. Numerator and denominator. So 3 over 2. 3 on numerator, 2 on the denominator, and those are going to cancel out. All right, I like to put the invisible 1 underneath the 4, the negative 4, so that I don't accidentally multiply the wrong terms. Negative 4 times 3 is negative 12. 1 times 2 is 2. And divide that out, you get negative 6. And again, there's a trickier way. You can go 2 goes into 4 2 times. 2 times 3 is still 6. Or negative 6. Last example. And then we're going to have to do some geometry and some word problems. I can't let you go on without it. Kind of a creature of habit. If you haven't noticed that, I typically always use X. Oh, sorry. I've already done the 1/3. It's 1/6. So 1/4 X plus 1/6 equals 1. All right, so we have to find a common denominator. If I choose to do the get rid of it method. I was pausing for dramatic effect. Okay. If I don't want to do the get rid of it method, if I want to do the deal with it method, well, then I don't need to worry about that. I can just bring the 1/6 over and deal with it, and then bring the 1/4 over and deal with it kind of as you go along. Again, my philosophy is if there's more than one fraction, just get rid of them. So the LCD, be careful, it is not 24, it is 12. Yeah. 4 is 2 times 2, 6 is 2 times 3, and so the LCD is 2 times 2 times 3. Which is 12, not 24. So let's multiply everybody by 12. I love this method because watch what happens. 4 goes into 12 3 times. 3 times 1 is 3x. 3 times 1x. 6 goes into 12 2 times. 2 times 1 is 2. Don't forget this side. This side also needs an LCD. 1 times 12 is just 12. There is no canceling. And now you have a nice elementary equation from some previous section in the book. Subtract 2 from both sides. You get 3x is 10. Divide by 3. You get x equals 10/3. Unless I tell you otherwise, leave that as a improper, reduced, or simplified fraction, unless the problem specifically says use mixed numbers. Okay, that pretty much wraps it up for all of the math techniques. Now it just becomes language, verbal translations, interpretations, and then some geometric formulas that again, I'm not introducing any new formulas. It's going to be quite a while till we get a new formula. But I'm going to use the formulas we already know. Triangles, rectangles, things like that. Let's start with the word problems. Might as well get those out of the way. So translate and then solve. Let x be the unknown value. Just makes it simple so that everybody's answers look the same. In the future, you will be able to choose your own variables for things, but I'm just going to choose for you today. So they'll all be x variables. Let's go through a few of the review terminologies. The quotient of a number and 5/6 is 2/3. So let's translate that first. Quotient means divided by. A number is x. The unknown value, a number, that means the same thing. This should say and. 5/6, that's 5 over 6. Is, that's equals, and then 2/3. So here's our translation. X over 5/6. Now you got to be careful here. You might want to put some parentheses to make sure that the 5/6 is clearly underneath the x. We will not be using the old school, dot, dot, divided by sign that you had in elementary school. We're moving on to the algebraic division, which is basically another way of saying a fraction. Is, and then 2/3. So that's your translation. Now we're going to solve it. We're going to solve it. Once I got it translated, I don't need all those words anymore. So now let's solve it. We have x over 5/6. I'm getting rid of the parentheses now, is 2/3. I'm going to multiply both sides by 5/6. Now, why am I not doing 6/5? Well, because it's not the coefficient. Look, it's denominator. So this actually means, if you're interested, if you just want to get the right answer, you can just tune me out now. But this actually means 6/5 x is 2/3. That's what this actually means. In other words, when you divide by a fraction, it's the same as multiplying by the reciprocal. And so when I put my reciprocal 5/6, there it is. 5/6. Look what happens. These guys cancel out. And I get x equals 10 over 18, which is 5/9. 10 is 2 times 5. 18 is 2 times 9, so it reduces to 5/9. Not too bad, huh? The problem with quotients is that it must be done in the right order, and you have to remember that the denominator gets flipped. And that's how you get the canceling. If you don't flip the denominator, then these things will not cancel, and your x will not be isolated. So you do need to be a little bit more careful with that. Same question. Translate and then simplify. The product of 3/2 and a number is 5/4. So let's translate it first. Product, multiply. 3/2 means 3 over 2. A number means x. Is means equal. 5/4 means 5 over 4. I don't really care which way you draw your division signs. Some people put them at an angle like that. Some people put them this way. It really is just a personal preference. It's not like there's a mathematical law for that. So we're going to translate 3/2 times a number. You can use a asterisk, which is shift, what is it? Shift 6? No, shift 8. on the keyboard to make a little star. It looks like a multiplication star. And then is, unless there's a pop-up menu, equals 5/4. I would also accept parentheses. Or I would also accept just putting the x off to the side. This is probably the simplest way to write it. But these are all tomato, tomato, tomate. It's all the same to me. Okay, and then now we're going to simplify this, or solve this. Let's multiply by the reciprocal, which is 2/3. And we're going to get x equals 10/12. 5 times 2 is 10. 4 times 3 is 12. And you want to simplify that. 2 goes into 10 5 times. 2 goes into 12 6 times, so 5/6. That's the quick way to simplify if you automatically know that they're both even. Yeah. If you have a fraction where the numerator and denominator are both even, you don't even need to show any work. Right? The top and the bottom are even, just divide them both by 2 and you get a simplified answer. If they still are even after doing that, then do it again until one of them becomes odd, and then you can stop at that point. All right, so I'm going to do the 4 basic operations: quotient, product, sum, and difference. Subtraction. The sum of 4/5 and a number is 9/10. Oh, it got blurry on me again. Come back to me. Having a hard time with the camera today. Maybe it's getting tired. Coming up on an hour already. My camera has ADD, has a hard time paying attention. Oh, there it is. Look, as soon as I said that, it comes back. All right. This one's relatively straightforward. Sum means addition. 4/5 means 4/5. A number means x. Is means equals. And 9/10 means 9/10. So, this is where I get the phrase, not every problem has to be a problem. All right. Some problems, especially in my class, are just gifts, right? They're not really problems. They're just giving it to you. So 4/5 plus a number is 9/10. Yeah. I would also accept in the opposite order. Because it's addition, you can change the order and the answer is still the same. Now you have to solve this. So we're going to subtract 4/5. And I get x equals, we'll multiply this one by 2 in order to get an LCD. So that'll be 9/10 minus 8/10. So the answer is 1/10. Again, if you wanted to check your answer before I end this lesson, you could just add 4/5 and 1/10. I'll leave that as a do-it-yourself. If you add 4/5 and 1/10, you will, in fact, get 9/10. 4/5 plus 1/10 is 9/10. Yeah. Okay, and then the last one is the last of these translation problems is the worst one. It's the one that oftentimes students get backwards. And I don't mean just students in this class. I mean students in pretty much every math class in the United States. maybe even around the world as well. 4/3 less than a number is 1/2. And I know I really hammer this one a lot because I want, if anything, when it comes to word problems, I want you to be able to translate subtraction properly. So this is the reverse order technique. A number is x, less than means subtract, and then 4/3 means 4/3, is means equals, and we all know what 1/2 is. It's 1/2. The most common mistake is exactly what I keep saying. Reading 4/3 less than and writing 4/3 minus, because that's the way it reads in English, and that's not the way it translates in mathematics. You have to reverse it. I don't think solving this is going to be complicated. Certainly not at this point. I mean, we're at example 14 of this lesson. So, I mean, I think you can take it from here. Just add 4/3 to both sides. I did make most of the common denominators in this section very easy compared to the previous sections where there was some really gnarly common denominators. In this section, they're all basically simple numbers, right? I'm not trying to, if you get some weird, 47 59ths or something, you definitely did something wrong in this section. It should all be very elementary fractions. So for this one, we're going to multiply it by 2. And on this one, we're going to multiply it by 3. So we've got 3/6 plus 8/6, which is 11/6. Okay. The last couple examples are geometry and a return to mixed numbers. So I will be specifying mixed numbers in these problems. And so you have to use mixed numbers, yeah. Basic rule of thumb is if a problem starts with fractions, it'll probably end with fractions. It's not 100% true, but it's pretty good odds. If a problem starts with mixed numbers, it'll more than likely, 9 times out of 10, end up being a mixed number. All right, let's find area first. We'll do area and perimeter. I'll do one of each. Let's find the area of the triangle. Sorry, we're going to find the height of the triangle. Given the area. I read it backwards. So I have a triangle like this. We already have done problems finding the area. Now I want you to find h. So it's, again, it fits right in with this lesson of solving equations. So find h. The base of the triangle is 13. So I'm giving you the base, and I'm giving you the area, and you're going to tell me what the height is. You need to memorize the formula. Area is 1/2 times b times h. And you don't need to use the dots for times. So I've got 50 and 1/4 is equal to 1/2 times 13 times h. If you prefer, you can use parentheses instead of dots. Now, this is going to be tricky because you have a mixed number and then you have an improper fraction. 13 times 1 is 13, and 1 times 2 is 2. So you've got kind of, conflicting notations. One of them is improper and the other one is mixed. So what I recommend doing is converting the mixed number into a improper. So convert this into an improper. It's a nice review of what we did earlier in the chapter. Okay, and so I've got 201 fourths equals 13 halves h. I'm going to multiply by the reciprocal of 13 halves, which is 2/13. Notice I'm not doing the reciprocal of 201 fourths because that doesn't have a variable. It's always the reciprocal of the coefficient. That's why I taught you that word an hour ago. Yeah. These guys are going to cancel out. I'm running out of time. I got to get to my office hours, but I think I got time for one more. And now I'm going to simplify this. Let's see. 2 times 201 is 402. 13 times 4 is 52. And now I want to switch back to mixed. So let's just do some long division over here. 52 goes into 402. I don't know how many times. About 7? I think 8's too many. 7 times 2 is 14. Carry the 1. 7 times 5 is 35. Plus 1 is 36. With a remainder of 38. So it's going to be 7 and 38 50-seconds. That's your H. I'm just writing it in the standard form. And these are both even. 38 50-seconds. Those are both even. So divide them in half. 38 divided in half is 17. No, it's not. It's 19. 38 divided by 2 is 19. 52 divided by 2 is 26. So that is the height of the triangle. Don't try using a calculator. You'll get decimals, and it'll just mark it wrong every single time. And it's very difficult to take the answer from a calculator and somehow arrive at this. It's not impossible, but it is so difficult. It's better just to do it the right way than to take out your calculator and try and type it all out like that. All right. I think I just got to run to my office hours, but let's see if I can squeeze in one more before we go. If you're waiting for me, I'll be there soon. What do I have to? Example 16. Perimeter. Find the width of a rectangle given that the length is 7 1/8. I didn't use any units last time. I think it was probably inches or centimeters or something like that. And the perimeter is 30 1/3 inches. Okay. So the perimeter of a rectangle. So let's just draw a little picture over here. A rectangle has 2 lengths and 2 widths. The perimeter is 2 W's plus 2 L's. If you divide everybody by 2, you get what's called the semi-perimeter. Also known as the half perimeter. Semi, mathematically, really just means cutting it in half. So semicircle, it's a half a circle. Semi-perimeter is half a perimeter. So the nice thing about this is you don't have two L's and two W's anymore. It makes it a lot easier to solve the equation, but you do have to divide the perimeter by 2. And again, if you try to do this on a calculator, you're going to get a decimal. It's going to go on forever and ever, and you're never going to be able to solve it correctly. Okay. So this means 30 1/2 divided by 2. I'm going back to the old school division sign. I know a minute ago I said I wasn't going to use it, but it's my last example. I'm just pulling it out of my hat here. Okay. So I'm going to convert this into an improper. 2 times 30 plus 1. So that's going to be 61 over 2 times 1/2. That's the reason why I use the old school division symbol, because it reminds me of 5th grade. Yeah? And when I remember 5th grade, then I remember all the rules about flipping fractions and things like that. I also know what L is. L is 7 1/8. Yeah, which I can write as 7 times 8 is 56 plus 1 is 57/8. Keep in mind, if you're getting confused, if you're getting lost, if you're thinking to yourself, oh my God, I'm never going to be able to do this on my own, you can do it. All right, you don't know you can do it, but you can do it. You never know until you know. All right, and just keep in mind, ultimately you're going to get a problem that looks almost just like every problem that we've done. So that's going to be 61/4. Yeah, 61 times 1 and 2 times 2. And then that's going to be W plus 57/8. I mean, it's geometry, so it's not going to have as nice of numbers. You're not going to get like 1/2 and 1/3. But, I mean, it's still the same basic idea. You have a fraction. You have a variable. You have an equal sign. You got another fraction. It's not that bad. It certainly could be worse. Okay? And we're this close to being done. We're this close. Our goal is to find W, right? That's our unknown value, W, right? I don't even need this other W. I've only got one W now. So I'm going to subtract 57/8. I know I'm kind of going backwards here. My W's on the right. I'm going to multiply this one by 2. I did mention earlier that the LCDs should be pretty easy. So that's going to be 122/8 minus 57/8. My brain is getting tired, so I'm going to do what I know you guys will do as well. Now, don't put the whole fraction, and I'm just doing the top. 122 minus 57, just because my brain is getting tired, 65/8. If you try to put the whole fraction into the decimal in the calculator, it's just going to blow up your calculator, give you a giant decimal. You'll never get the right answer. All right? And then switch back to mixed. So 8 goes into 65 8 times with a remainder of 1. So it's 8 1/4, and that is your answer. Okay, I had to kind of hustle through those last two geometry problems, but I mean, there's only 2 geometry problems in the whole assignment. So if you need any additional assistance, I'm running a little bit late to my office hours, but I will see you on the internet.